So, by 2030, the instant grocery delivery market alone is projected to hit like $637 billion globally.
Which is just a staggering number.
Right. I mean, to put that in perspective, that is larger than the entire gross domestic product of Sweden.
Oh, wow. Yeah.
Yeah. And if you look at just standard online food delivery, the U.S. alone generated an estimated $432 billion in 2025.
Right. Which puts them sitting right behind China, I think, is the second largest market on Earth.
Exactly. But I think the most surprising part of this absolute economic juggernaut isn't actually the scale of the money.
Okay.
It's the fact that the companies dominating this space, the apps you tap every single Friday night, they are rarely building their software from scratch.
Right.
They're using blueprints. So today, our mission in this deep dive is to completely unpack one of those blueprints.
Yeah, we've got a really fascinating source today.
We do. We have our hands on a comprehensive guide detailing exactly how to build a multi-million-dollar delivery empire using a Foodpanda clone as the source material. So we're going to look under the hood at the mechanics, the tech and the business models that basically power the invisible infrastructure of your city.
It really completely shifts your perspective when you realize that these seemingly bespoke, like highly polished apps are often built on standardized foundational frameworks.
Yeah.
Because when entrepreneurs look at those massive revenue numbers you just mentioned, they aren't thinking about, spending 5 years writing code in a basement.
Right. Nobody has time for that.
No, they're looking for a structural framework that has already solved the hardest logistical problems for them.
Okay, well, let's unpack this, because I think when a lot of people hear the word clone, they immediately think of something, sketchy.
Oh, absolutely.
They picture someone ripping off a company's logo or illegally copy-pasting proprietary source code to make some kind of cheap knockoff.
Yeah, and that is a massive misconception that we really have to dispel right away. In the software development world, especially for like enterprise-level marketplaces, a clone is about recreating a proven business workflow.
Okay, so it's not stealing.
No, not at all. Think of it like building a modern skyscraper.
Okay.
A developer doesn't invent a new way to pour a concrete foundation, right?
Ew.
Or a new way to wire an elevator shaft. They use a proven architectural floor plan because they know those physical mechanics work safely.
Oh, I see.
So a software clone provides that foundation. You can build it from scratch following the logic, or you can buy it as a white-labeled, self-hosted solution.
Where you customize the exterior.
Exactly. You brand it, but you rely on the pre-built internal logic.
That makes total sense. And the model we're analyzing today is based on Foodpanda, which is just a behemoth.
Huge.
I mean, they are a subsidiary of Delivery Hero, operating in over 400 cities across 11 Asian markets.
Yeah, the scale is unbelievable.
Right, so to operate at that scale, this can't just be a simple menu app on your phone. In the sources, the architecture is described in 4 distinct pillars. But honestly, as I was reading it, I realized it operates a lot less like a digital restaurant and a lot more like an air traffic control system.
That is a much more accurate way to look at it, actually.
Yeah.
Yeah, because you have 4 entirely different groups of people who need to look at the exact same radar screen in real time, but they all need completely different tools to interact with it.
Right. So let's break down this air traffic control tower. The first pillar is the admin panel.
The control room.
The control room, exactly. This is the tower itself where the platform owners sit.
Yeah, and this is where administrators manage the overarching ecosystem.
Okay.
It's not just about looking at, sales analytics. This dashboard manages multi-city rollouts.
What does that mean exactly?
Well, if you want to launch your delivery app in a new city, you don't build a new app.
Oh, okay.
You use the admin panel to define the geographic boundaries, set regional tax rates, and configure specific payment gateways for that local market.
So it's all handled from one central hub.
Yes.
It handles the incredibly complex routing of funds, splitting the money between, digital wallets, credit card processors, the restaurant, the writer, and the platform itself.
Wow.
And it does all of that in a fraction of a second.
That's wild. Okay, so then you have the second pillar, which would be the passengers in our metaphor.
Right.
The user app.
Right, the front door.
The front door,
Yeah.
and it's the only part the customer ever sees. But the level of functionality hidden behind just a simple search bar is wild.
Oh, yeah.
It has to handle advanced search and filtering, specific ingredient customizations, secure payments, tipping, all of it.
And the hidden mechanical hurdle in the user app is multi-order placement.
Okay, break that down for me.
So depending on the platform's multi-vendor setup, a user might place a single order for a burger from one restaurant and a coffee from a cafe down the street
In one cart.
in one cart.
So the user app has to instantly split that single transaction, send two different tickets to two different vendor dashboards, calculate two different prep times, and coordinate the logistics so the items arrive at your house together.
That sounds like a logistical nightmare.
It is, which perfectly tees up the third pillar.
The airlines or the restaurant and grocery dashboard?
Exactly. The vendors have a completely separate interface. They use this to customize their menus on the fly, manage incoming order queues, track which delivery driver is assigned to which bag of food, and run promotional deals.
Right, to boost their visibility and stuff.
Yeah, exactly.
And finally, you have the planes. The fourth pillar is the rider app.
The logistics wing.
Right, and this is arguably the most complex piece of the puzzle because it has to manage a highly decentralized, constantly moving workforce.
Yeah, it handles rapid digital onboarding for independent contractors, document verification, all that.
But the real heavy lifting is the route optimization engine, right?
Oh, absolutely. It is constantly analyzing live GPS data across the entire city fleet to identify the nearest available driver and assign them the absolute shortest route, factoring in traffic.
But wait, a detail in the source material really caught my eye regarding this.
Okay, what was it?
The Rider app explicitly includes the mechanism for the rider to accept or reject an order.
Yes.
If the system is automatically pinging the absolute closest, most efficient driver, why give them a button to just blow up that efficiency?
Because you're bumping into the fundamental tension of the gig economy right there.
Oh, interesting.
Yeah, these platforms rely on independent contractors, not hourly employees. So legally and operationally, the rider must maintain autonomy.
I see, so you can't force them.
Right. If the platform forces a rider to take a specific route or a specific order, they risk classifying that rider as a full-time employee, which completely breaks their financial model.
Oh, wow.
So the software has to balance mathematical efficiency with human autonomy. It pings the closest driver, but if they reject it, the algorithm has to instantly recalculate and ping the next best option within milliseconds.
That level of constant recalculation requires a massive engine.
It does.
And this is where we get into the actual construction of this digital infrastructure. The source material outlines the tech stack required to hold this all together.
Right. So the mobile apps themselves, the user and rider apps, they're typically built using cross-platform frameworks,
Like what?
like React Native or Flutter. This means developers only have to write the code once for it to work on both Apple and Android devices.
Oh, that saves a lot of time.
Huge time saver. Or they might use native languages like Swift and Xcode for iOS and Java or Kotlin for Android if they need slightly better performance.
Okay, but the app on my phone is essentially just a remote control, right? Like it doesn't store the menus or the maps.
Exactly. It's just displaying data being beamed from the back end. Things like Node.js or Nest.js paired with a robust database like PostgreSQL or MongoDB.
Right. And the source mentions that the real magic for the live order tracking is a technology called WebSockets.
Ah, yes. The secret sauce.
Yeah, and I know what a standard internet connection is, but what exactly is a WebSocket and why does this ecosystem completely depend on it?
Okay, to understand WebSockets, you have to understand how standard web browsing works.
Okay, lay it on me.
Normally, when you click a link on a website, your browser sends a request to a server, the server hands over the web page, and then they hang up the phone.
The connection closes.
Right, it closes. It's a one-way, single-use request. If you applied that to a delivery app, you would have to manually refresh your screen every 3 seconds to see if your driver had moved.
Oh, that sounds like a nightmare.
It would be entirely unusable. So instead, the platform uses WebSockets. A WebSocket creates a persistent, two-way open line of communication between your phone and the server.
So they don't hang up the phone.
They do not hang up. The line stays wide open. This allows the server to continuously push the rider's changing GPS coordinates directly to your screen in real time.
Oh, wow.
Yeah, that technology is exactly what feeds our modern impatience. When you find yourself obsessively staring at that little car icon, making a wrong turn down a one-way street.
I do that all the time.
Right. You are watching a WebSocket connection in action, and it integrates with things like Google Maps or Mapbox and push notifications via FCM or APNs to keep everyone updated.
Okay, so we have the 4 pillars, we have the tech stack, we have the WebSockets. The source material maps out an 8-step blueprint to actually launch this business.
Yeah, and it's a pretty grueling process.
Let's run through it. Step 1 is market research, finding your target audience and competitor weaknesses. Step 2 is deciding the business model. Step 3, local laws and permits. Step 4, partnering with restaurants.
Right.
Step 5 is development, front end, back end. Step 6 is testing for bugs. Step 7 is deployment to the App Store or Google Play. And Step 8 is ongoing maintenance.
That's the basic roadmap, yeah.
And I want to pause on the cost aspect of this because I saw a number that stopped me in my tracks.
The MVP cost.
Yes. The source estimates that a basic MVP, a minimum viable product, can be built for around $30,000 in just 2 to 4 months.
Yep, that's accurate.
Wait, you're saying I can buy a clone script for 30 grand, spend a summer tweaking it, and launch a competitor to Uber Eats? That sounds way too good to be true. Where is the hidden catch?
The catch is that building the software is only about 20% of the battle.
Okay, what's the other 80%?
The other 80% is a brutal gauntlet of real-world logistics. That $30,000 gets you a functional piece of software. It does not get you a business.
I see.
If you look at the 8 steps outlined in the blueprint, the friction points aren't really in the code. They are in the streets.
Like the classic chicken and egg problem.
Exactly. Step 4 in the blueprint is partnering with restaurants. How do you convince a local pizza shop to integrate your tablet into their workflow when you have 0 active users on your app?
You probably have to subsidize it.
You do? The source suggests offering massive zero-commission deals just to get them on the platform. But then, how do you get users to download the app when you only have 3 restaurants available?
You have to burn cash on marketing.
A lot of cash. Not to mention step 3, which is navigating local laws.
Right, you can't just flip a switch and launch a digital business that physically moves goods through a city.
No, you are dealing with local commercial permits, food handling compliance, and independent contractor licensing.
And all of that varies wildly from one zip code to the next.
Exactly. So while an MVP might cost $30,000, a standard, fully functional platform ready for real market penetration is roughly $70,000 and takes 4 to 7 months to configure.
And if you want an advanced marketplace with, like, custom integrations?
Then you're easily looking at $150,000 and over a year of development. Plus, you'd probably want to add custom features like multilingual support, light and dark themes, maybe even Bluetooth invoice printing for the restaurants.
Okay, so let's assume a founder successfully navigates that gauntlet. They spend a $70,000. They solve the chicken egg problem. The app is live.
Okay.
How does this massive air traffic control system actually pay for itself? Because I think the average consumer assumes that the $3 delivery fee covers the whole operation.
Oh, the delivery fee is just a fraction of the revenue, and it heavily fluctuates based on distance and peak demand pricing anyway.
So what's the main source?
The primary engine driving this entire industry is the commission fee. The platform deducts a significant percentage, sometimes up to 30%, from the customer's total payment before passing the remainder on to the restaurant.
30%, that's huge.
It is. But the source outlines a much deeper monetization strategy beyond just taking a cut of a sandwich.
Right. They talk about in-app advertising, where restaurants pay to bypass the algorithm and sit at the top of the search results.
Very common.
They talk about subscription models, like paying a monthly fee for free delivery.
Like Uber One or DashPass.
Exactly. And then there's the data monetization.
Ah, yes. The behavioral data is the real goldmine.
Here's where it gets really interesting, because the source casually mentions analyzing anonymized ordering habits to sell industry insights.
Right.
But if this app is tracking the real-time location data of thousands of riders, the credit card data of tens of thousands of users, and the dietary habits of an entire city, isn't that an absolute liability nightmare? Especially if the app gets hit with a massive surge of traffic, like on a Friday night during the Super Bowl.
Well, you've just articulated the 2 biggest existential threats to any platform administrator. Server crashes and data breaches.
Yeah, it seems terrifying.
Let's tackle the Super Bowl scenario first. When thousands of people try to order hot wings at the exact same moment, standard servers will just buckle under the sheer volume of concurrent database writes.
And if the app crashes, everything stops.
Everything. The riders are stranded, the restaurants throw away cold food, and you lose customer trust instantly.
So how do you physically prevent that crash?
You don't rely on a fixed number of servers. You use cloud infrastructure like AWS or Google Cloud that allows for dynamic load balancing.
Load balancing, how does that work?
The system monitors incoming traffic, and the moment it senses a massive spike, It automatically spins up additional virtual servers to distribute the weight of those requests.
Oh, that's smart.
Yeah, and they also use techniques like lazy loading.
Lazy loading.
Yeah, where the app only renders the images visible on your phone screen at that exact moment, saving crucial bandwidth.
Okay, that handles the traffic. But what about the security liability? If I'm handing over my credit card to a brand new clone app I just downloaded, how do I know it's safe?
That is where strict compliance protocols come in. The blueprint dictates using PCI DSS compliant payment gateways.
Right.
But the real mechanism protecting you is tokenization.
Okay, I've heard that term. How does that work in practice?
Think of tokenization like a coat check at a museum. When you hand over your expensive coat.
My credit card data.
Exactly. You hand it over, and the attendant gives you back a cheap little paper ticket with a number on it. That ticket is the token.
Okay.
The platform's database only stores that paper ticket. It never actually stores your credit card number.
Oh, I see. So if a hacker breaches the database...
All they walk away with is a digital pile of useless paper tickets that have zero value outside of that specific system.
Wow, that's actually really clever.
Yeah, and you combine that with encryption for data moving between the phone and the server and regular security audits, and you mitigate a lot of liability.
It is staggering how much defensive engineering is required just to deliver a pizza.
It really is.
But assuming a founder pulls this off, the app is stable, it survives the Super Bowl rush, the data is tokenized and secure, and it's turning a profit. Customer retention in a market flooded with Uber Eats, Deliveroo, Grubhub, Just Eat, DoorDash, it's incredibly difficult.
Oh, it's a bloodbath.
Right. You can offer loyalty programs and push notifications all day long, but eventually people get notification fatigue. What is the ultimate end game for a platform like this?
If we connect this to the bigger picture, the end game isn't about food at all.
What do you mean?
The source material provides a fascinating case study that completely redefines what this architecture is capable of. It is a platform called Lumi.
Right, Lumi. Qatar's first AI-powered super app. This part of the blueprint completely blew my mind.
It's a masterclass in platform evolution. Lumi was built using the Enatega framework, which is a highly customizable open-source clone architecture.
Okay.
It was designed to align with Qatar's National Vision 2030, heavily focusing on a unified digital economy. But here is the critical detail. Lumi didn't start as a food delivery app.
They launched as a ride-hailing service.
Correct. They started with ride-hailing, utilizing an AI-powered peer-to-peer fare negotiation system.
Wait, fair negotiation?
Yeah, you could open the app, and instead of just accepting a flat rate, you could negotiate the price of your ride in real time.
That's awesome.
It is. But because they built the foundation on a multi-vertical clone architecture, meaning an architecture designed to handle multiple different types of businesses simultaneously, they didn't have to start from scratch when they wanted to expand.
This is the genius of it. When they decided to move into food delivery, they didn't force their users to download a separate app like Lumi Eats.
Exactly.
They just seamlessly integrated the food delivery ecosystem into the exact same app the users already had on their phones.
Yep. And then they added grocery ordering, and then hotel deals, and flight searches.
All centralized in a single interface.
The business strategy behind that is profound because it solves the most expensive problem in tech, which is customer acquisition cost, or CACs.
Right, CAC.
Usually an app spends a fortune marketing to get one user to download their app for one specific service.
Right.
By using a unified digital wallet inside a super app, Lumi acquires a customer who just wants a ride to the airport. But because the wallet is integrated, that same customer can book their hotel, order room service to arrive exactly when they check in, and arrange their flight home, all without ever typing their credit card into a new platform.
And from the admin panel's perspective, that air traffic control tower we talked about, the administrators are managing the taxi fleet, the restaurant menus, and the hotel availability through one unified backend instead of duct taping 3 different companies together.
It drastically reduces overhead and creates a walled garden for the consumer.
A walled garden, meaning they have no reason to leave.
Once you are in the super app, there is no logistical reason to leave. This highlights the real opportunity in the modern market. Taking on global giants like Deliveroo or Grubhub in a general market fight is a losing battle.
Yeah, you're not going to win that.
No. The success stories are the platforms that find a highly specific niche.
Like Hungry Panda, which the source mentions, they specifically target authentic Asian cuisine and cater the entire user experience to Asian communities, rather than just trying to appeal to everyone.
Exactly.
Yeah.
Or, like Lumi, you build a hyper-localized super app tailored to the specific digital goals of a single country or region.
Right.
The multi-vertical software clone is just the vehicle. The actual innovation is how perfectly you can map that vehicle to the local culture and economy.
So what does this all mean for the listener who just wants to understand the digital magic happening on their phone, or maybe the entrepreneur looking for an entry point? The takeaway is pretty clear.
Yeah, what's the bottom line?
Building a digital empire today doesn't require locking a team of engineers in a room for 3 years to write millions of lines of code from scratch.
Right.
By utilizing a multi-vertical clone architecture, the foundational heavy lift, the WebSockets, the tokenization, the route optimization, it's largely handled for you.
Which is huge.
It is. It frees a founder up to focus on the things that actually dictate survival. Navigating local commercial compliance, hustling for the best restaurant partnerships, and designing a business model that scales.
It shifts the entire entrepreneurial mindset. You stop asking, how do I build this complex technology?
Right.
And you start asking, how can I deploy this proven technology to fundamentally reorganize the logistics of my city?
Wow, yeah.
Which raises a rather profound question when you look closely at the super app model. Think about the trajectory we've unpacked today.
Okay.
If a single platform can start by delivering your dinner and then expand into managing your groceries, evolve into coordinating the cars you ride in, and eventually handle your travel bookings,
Yeah.
all while processing secure, tokenized payments and analyzing the intimate behavioral data of an entire population, at what point does the app on your phone stop being just a convenient service and start becoming the actual invisible infrastructure of the city itself?
That is heavy. It makes you look at that glass screen a little differently, doesn't it? The next time you tap a picture of a burger on a Friday night, just remember, you aren't just ordering dinner. You are interacting with the blueprint of a digital empire.